presenting today. And I'll turn it over to you to go ahead and introduce yourself and the topic.
Sure, thank you, Mike. Like Mike already mentioned, my name is Zafar Mohammed. I'm an Azure Technology Solution Professional in Azure App Dev Space here at Microsoft with more than 8 years of experience in Microsoft Azure. Today's webinar is on serverless architecture in Azure. Like Mike already mentioned, we are going to be recording this webinar for on-demand viewing as well. And that's one of the reasons I would like to keep the Q&A session to the end. So without further delay, let's get started. In this era of digital transformation, you can architecture applications in several different ways, starting from traditional way of N-tier SOA applications on-premise or IaaS, which is infrastructure as a service, or to PaaS, which is platform as a service in the public or private cloud, where servers are there but managed by the cloud providers. Azure has gone a step further now, and the next iteration of platform as a service is serverless. Fundamentally, serverless architecture is the next evolution of cloud services built on the top of PaaS, abstracting away VMs, application frameworks, and external dependencies via bindings so that developers can focus simply on the code to implement business logic. So now, if you think about what the benefits are for serverless, the focus with serverless is to solve the business problems, not the technology. So you focus on the code, not the underlying plumbing. This provides flexibility through simplified starting experience, easier experimentation, auto scale feature, and its suitability for microservices. The platform is efficient with shorter time to market, fixed costs converted to variable costs, better service stability, better development and testing management, and less waste. The four main services in Azure Service Platform, Azure Serverless Platform, are Azure Functions, Event Grids, Logic Apps, and Storage. Azure Service Application Platform, together with all the other additional services that it has and the development environment it provides, you with an innovative programming model for faster development, comprehensive set of platform services to build upon, like I already mentioned, and then superior developer tools and excellent integration with CI/CD and CI/CD for Azure DevOps and monitoring tools for monitoring your applications and the infrastructure. So starting with Azure Functions, Azure Functions is basically FaaS, or function as a service, which is the center of serverless. Functions as a service programming model uses functions to achieve true serverless compute.
Okay.
Functions are single purpose reusable pieces of code that process an input and return a result. Functions don't stick around when finished executing, freeing up resources for further executions. Functions don't hold any persistent state and don't rely on any state of other processes. Functions respond to predefined events and are instantly replicated as many times as needed. Functions also provide integrated programming model, enhanced development experience, and flexibility in hosting options. Azure Functions boost the development efficiency. You can use triggers to define how functions are invoked. Example through HTTP request or blob uploads, which are otherwise called HTTP triggers and block triggers when you see in the portal. It lets you create endpoints as reverse proxy to other APIs or to bind to Azure solutions and third-party services through input and output bindings. They let you use debugging tools in Azure Portal, VS, and Visual Studio Code, or Visual Studio and Visual Studio Code. You can deploy functions using app service for continuous integration, or leverage Microsoft DevOps tools like Azure DevOps for your continuous delivery. And you can get real-time details about Azure Function apps using several different monitoring tools, like I mentioned before. The one thing worth noting here is that the HTTP trigger function API can be exposed through API managements, which was discussed in the previous webinar, for adding security and protection to your functions. Continuing with Azure Functions, it provides support for multiple languages like C#, JavaScript, F#, and Java, and even Python, which is in preview to my knowledge. You can also write stateful functions in serverless environment with durable functions extension. The extension makes it possible to manage state and checkpoints. Otherwise, as stated before, functions by itself are stateless. While we're talking about functions, since we also talked about the development tools, here's a Microsoft Visual Studio editor IDE available for you, from where you can create a simple function app with Azure SDK installed in your development machine. Once your Azure SDK is installed and Azure Function templates are installed, all you have to do is go and create a new project, and you would see Azure Functions here. Continue with the process, and then it will ask you what kind of template that you would like to use, whether you want to use some kind of block trigger or an HTTP trigger or so. So that's how I created this sample function app here in Visual Studio using the HTTP trigger. And you can continue working on the function, like whatever code that you would like to write in function, whatever actions that you would like to do in this function, you do that, and then simply deploy it by publishing it to Azure. So when I click on Start, it would probably ask me for how you would like to deploy, and it's selected Azure App Service, which is one of the hosting modules for Azure Functions. So this is how you continue and publish it to Azure. So you have a Visual Studio IDE tools to deploy your functions from your development machine, or you can as well use Azure DevOps to have your code in place in Azure DevOps and use the Azure DevOps build and release pipelines to build your code and deploy to Azure. Quickly going back to the slides. Like mentioned before, there are 6 hosting options: consumption plan, app service plan, IoT edge devices, AKS, service fabric mesh, non-Azure host, and on-premises with app service on Azure Stack. Like I mentioned before, or in the previous slide, Azure Functions SDK is available to develop and run locally on development machine with IDEs like Visual Studio and Visual Studio Code for your open source projects. One thing that you have to watch out for when using consumption model instead of dedicated Azure App Service is the code start involved with consumption plan, as resources are being allocated on demand, unlike Azure App Service plan, where you have resources dedicated. Now moving on to the next service, which is part of the Azure application, Azure Serverless Application Platform, Azure Logic Apps. Azure Logic Apps is a cloud service that helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate apps, data systems, and services across enterprises or organizations. Logic Apps simplifies how you design and build scalable solutions for app integration, data integration, system integration, enterprise application integration, and business to business communication, whether in the cloud or on premises or both. A few workloads that you can automate with Logic Apps, like process and route orders across on-premise systems and cloud services, or to send email notifications with Office 365 when events happen in various systems, apps, and services, or to move uploaded files from an FTP to or FTP server to Azure storage. Some of the workloads that I just mentioned are not just implemented alone by Logic Apps, but in combination of other services like Azure Functions, event grids, and other services included in the serverless application platform. To build enterprise integration solutions with Azure Logic Apps, you can choose from a growing gallery of 200 plus connectors, which include services such as Azure Service Bus, Functions and Storage, SQL, Office 365, Dynamics, and the list goes on. These connectors provide triggers, actions, or both for creating logic apps that securely access and process data in the real time. The other service is Event Grid, which is a fully managed intelligent event routing service that allows for uniform event consumption using a publish subscribe model. You use Azure Event Grid to react to relevant events across both Azure and non-Azure services in real-time fashion. Azure Event Grid allows you to easily build applications with event-based architectures, where first you select the Azure resource you would like to subscribe to, and then give the event handler or webhook endpoint to send the event to. So in this case, blob storage events that you'd like to subscribe to are published from blob storage and sent to event grid, and from event grid, the handlers from Azure Functions or Logic Apps or other available handlers will handle those events. Azure Event Grid provides several features that vastly improve serverless ops automation and integration work. Event Grid connects data sources and event handlers. For example, use Event Grid to trigger a serverless function that analyzes images uploaded to a blob storage container, or Event Grid allows you to speed automation and simplify policy enforcement. For example, use Event Grid to notify Azure automation when a virtual machine or SQL database is created. Event Grid connects your app with other services. For example, create a custom topic to send your app's event data to Event Grid and take advantage of its reliable delivery, advanced routing, and direct integration with Azure. There are multiple messaging services available in Azure, like you already know, like Service Bus, Event Hubs. The main differentiating factors for Event Grid are elimination of polling, near real-time delivery, massive scale-out, and high reliability. In some cases, you see the services side by side to fulfill distinct roles. For example, an e-commerce site can use Service Bus to process the order, Event Hubs to capture site telemetry, and Event Grid to respond to events like an item was shipped. This is a repetition of what I just mentioned in the previous slide about what all can be achieved with Event Grid. While we're on the slide, I would like to quickly show you a document which talks about, which shows you how events published by Azure resources like Azure Virtual Machine can be sent to the event grid topic, and that event grid topic is handled by the Azure Logic app, which happens to be one of the subscribers, like we saw in the slide that some of the event handlers are basically Azure Functions and Azure Logic apps. So here, as you can see, in Azure Logic app, it's listening or it's handling the events from Azure Event Grid or a resource event like Azure Virtual Machine event. And that event, when that event is fired and is handled by Azure Logic app, you follow up with certain things as to what you would like to do. You continue in that Logic app. And then after that, whatever actions that you would like to take, whether you would like to send an email to email notification to the users of those virtual machines for the changes that have happened in the virtual machine, or do any other or take any other action. And all those actions are possible through the many enterprise integrations that I mentioned on the slide. So one of the enterprise integrations that I mentioned in the slide was Office 365, and that's how we are able to send email from Office 365 over here. Moving back to slides real quick. Finally, Azure Storage is also serverless now. I mean, you might wonder, what am I talking about? Well, you can now host your static websites on Azure Storage. You can create an Azure Storage. You can enable Azure Storage for static websites and then upload your web content to the storage account. And when it's uploaded, there's certain steps that you need to take. When that's taken, that those files are uploaded to a container like $web in your storage account, and you will get a endpoint for your web application, and that endpoint would basically be your website address, which I will walk through when I'm going through one of the demos in some time. Here's a good serverless architecture scenario that I picked from Microsoft Cloud Workshop Serverless Architecture available on GitHub. The goal here for this problem was to automate license plate picture capture. The car or any vehicle, motor vehicle license plate picture capture at a toll booth station and analyze those images for customer billing purposes. One of the many viable solutions, this is the solution that you see here, the architecture that you see here, is one of the many viable solutions where it uses Azure Event Grid, Functions, Logic Apps, and cognitive services. Azure Event Grid, Functions, Logic Apps, these are the serverless application platform services that we talked about. This works in conjunction with, along with the cognitive services, computer vision API to analyze those pictures that are uploaded, and get the result that's needed for this problem scenario. This is a good scenario, like I said, to understand how the publish subscribe eventing model of Azure Event Grid, Azure Functions, HTTP and blob triggers, or Cosmos DB binding, and Azure Logic Apps business workflow works together to create a serverless app. So here, as simple as this solution is whenever there's a vehicle that passes through the toll booth station, the picture is taken and the picture is uploaded to Azure Blob Storage. And as soon as the picture is uploaded to the Blob Storage, Azure Event Grid eventing basically Azure blobs blob upload event is published or fired, and that's sent to Event Grid, Azure Event Grid. Azure Event Grid has like Azure Functions that are subscribed to those events on that particular Event Grid topic, and then it takes it from there and continues to execute the relevant Azure functions that are fired and does the background processing along with other services like Cosmos DB to save the data through the bindings that are available for Azure Functions. In the same architecture, you also see the logic apps where it basically is available to like send out email notifications for certain things to the customers or any other any other entity available in the workflow. Moving on, we'll actually go through a demo on Azure Serverless Application Platform. So I will quickly talk about the demo, the platform that. Sorry, just a second. This is the Azure Serverless Web Application that I deployed to Azure, and this is out there for you to look through it. This is essentially a application where you're using all these Azure services like Blob Storage, Azure Functions, Cosmos DB, Logic Apps, and Azure Active Directory. Blob Storage here serves static web content and stores images. Azure Functions manages image uploads, resizing, resizing, and metadata storage. So let me just go back real quick to the actual architecture diagram for you to understand it. So the diagram here shows, I'm going to repeat this information here. The diagram here shows the Azure services used by the application. Blob Storage serves the static web content and stores images. Azure Functions manages image uploads, resizing, and metadata storage into Cosmos DB. Then Logic Apps gets image captions from Computer Vision API, to display it for the images that are uploaded into the application. So I will show you the application itself first, and then we'll walk you through in Azure portal as how all those services are kicking in. So here's the application that I have, which is hosted in serverless Azure storage. So Azure storage, static websites, it's up there. I upload a file here. I browse it and select one of the files and upload it. Okay, so the image has been uploaded and uploaded to various different blob containers that is supposed to upload in the backend. And then the image is analyzed by Computer Vision API, and it should be showing uncaptioned as to what that image is about. Unfortunately, I have something going on in the backend in the code because of which the captions are not showing up. But I can certainly show you like what kind of captions would actually show when the Computer Vision API is called. So this is what I would expect if I browse the same image here. This is the Computer Vision API out there in public for you to analyze, a public link on Azure documentation. As you can see, here's the description of the photo that comes up, the same picture that I put out there, a person sitting in a boat on a body of water. So this is exactly what I would have expected here as well with my computer services, Computer Vision API that I'm calling through the Azure function. But for whatever reason, it's not working. So I'll still have to debug that basically. But in any case, I will go back to Azure portal now and show all those entities that I have in place, or all those resources that I have in place to make this serverless web application up and running in Azure. So here's my resource group. I have my open source single page application, static website, hosted in the Azure storage account. So this is my storage account. Here you have the option of static website. When you create a storage account, if you want to enable the static website, you have to go and click on enable here. Otherwise, by default, it is disabled. Okay, so when you enable it, you get this primary endpoint. When you enable it and give the index document name here and save it, then the primary endpoint will show up. Otherwise, the primary endpoint text would be empty. Once you save it, it will show up. And this would be the address of your website, which is what it is over here. Okay, so that's the piece of Azure Storage Serverless. Now, let's. I also want to show you two more containers here in Azure Storage before I go to Azure Functions. So if I look at the blobs, there should be 3 containers here, or actually 4. One for web, which is where the content of my website is existing. And then I have the other containers like images and thumbnails, which is what I'm using for Azure Functions. Okay. Images is something where I am uploading the images. Then once those images are uploaded, basically resizing those images using Azure Functions and putting it in thumbnails. And from thumbnails, while putting it in thumbnails container, I'm also executing cognitive services computer vision API from one of the Azure functions to analyze the picture description that I would like to see on the picture itself. So if I go back to Azure Functions now, here is my Azure Functions function app. And like I mentioned before, you can write Azure Functions directly over here by creating Azure Functions app in Azure from the portal, or you can also create Azure Functions app from Visual Studio. So I have created it in the portal and added several functions, several different functions over here. So the way you add the function in the resource group where you would like to have all your resources in place is by just finding a function app in the marketplace. So you have the function app here. You select the function app. When you create it, it's going to ask you for several different parameters that you would like to have to choose. And once you choose it, it will basically create the function app. We talked about the hosting plan. There are several different hosting plans available. Here's what you have available here for as consumption plan and app service plan. Like I mentioned, app service plan is like a dedicated app service plan where you have resources dedicated for your function app. And consumption plan is like an on-demand resource allocation where no resources are allocated. And this is where you have to watch out for the cold start. All right, so I'll just go back to the function that I've already created to talk about some of the functions there. So here's the function app. So get upload image URL is one of the functions which is based on HTTP trigger. So if you click on this test, you can see that this is like a HTTP get method where you're getting the upload URL method and get upload. Sorry, where you're getting the URL for the image file that has been uploaded to the storage account, and this function is being triggered. So if I go back to my slides, this is exactly where it's coming from. So you have an image uploaded here. You have get image URL that gets triggered with this HTTP trigger of getting that URL, that blob image URL. And once that image Azure function is fired, then you have that image uploaded in the images container that I showed in the storage account. And once that image is there in the images container, this resize image Azure function is triggered, because Azure function resize image is actually based on a blob trigger, which is something that you can see over here. So if I go to the resize image and look at the test again, as you can see, the request body, it's expecting some kind of file to be there, or some kind of file to be up there in the container. So which is what I have to provide. I have to provide the container address, the storage container address, and the file itself. And this would basically trigger this trigger the Azure function. And once that Azure function is triggered, it basically takes that file from the images container, changes it to a thumbnail. It basically changing it as a thumbnail, and that thumbnail, and also analyzing the same picture for the description by calling into the computer vision API. One thing to note here in this architecture diagram is that I'm calling this Azure. As per the architecture, you're expecting the computer vision API to be called from Azure Logic Apps, and then saving the data description or the image description metadata into the Cosmos DB. However, in my case, I have not used the Azure Logic Apps, but have instead used the Azure Functions. And Azure Functions, as you can see here, here's the piece of code in resize where I'm calling the computer vision APIs in the cognitive computer vision API in the cognitive services, in Azure Cognitive Services. And once this Azure function is triggered, I'm basically saving that information and saving the metadata information into the Azure Cosmos DB. And once it's into Azure Cosmos DB, the last piece in this, what I'm doing is getting the list of images onto this public website, all those images that are uploaded along with the description of that image that's picked up from the Azure Cosmos DB. So this is how all these different services on the serverless application platform work together for you to be able to build a web application based on the serverless architecture. So that's all I had. If you have any questions, I would be glad to answer them.
So really quick, Safar. So could you go back to the first diagram, the one with the license plate reader one?
Yeah, sure.
This one. Okay. So I really like this diagram. And the reason why I really like this diagram is because it does show all the different building blocks that we have for a full solution. So like we start with the vehicle photos. I mean, this is something that we see a lot with our customers in Department of Transportation. We see this all over the place where they've got different license plate readers. Now, this could be at toll booths, but we're also seeing this being done with police vehicles, just driving around with cameras that are pointed down as they drive past parking locations and stuff. And basically being able to capture those images and then having them sent up to blob storage. And as you see here, we don't have any virtual machines anywhere in this. This is all completely serverless. So the files are going into blob storage. The event grid picks up on the new file event. The Azure, then basically you've got all these functions that are listening to different topics on the event grid. And so on the incoming one, we go over to the Azure function, we do a computer vision check. So basically we're doing the OCR on the license plate, and then that data goes back in, the results back into the event grid, which then gets picked up by other functions, which then take that data that's successfully processed. We put it in Cosmos DB. We're taking data that is then put in Cosmos DB. We're triggering off of that. to run another license or another function down at the bottom, which basically is exporting the license plate data to CSV and then sticking that into blob storage. So this is really interesting because we're doing lots of different things here. We're storing the images. We are doing computer vision. We are taking the results of the processing. We're putting that into a database that can be used for manual verification if necessary. Then it exports it to CSV files, stores that into blob storage that can be used later on for further, maybe billing or whatever. And then you've got a logic app there so that if there's maybe an issue where a license plate was not able to be read, you can notify somebody that there was a problem and have someone go and manually view that. So I find this absolutely fascinating because nowhere in here do we have a web server. Nowhere in here do we have a virtual machine. The one thing that we didn't talk about either that I just wanted to highlight really quick is application insights. Application insights is a great way to monitor all of this because application insights is our big data processing where it takes the performance of these different items and tracks it. We can also embed telemetry kind of triggers in each of these things. So when certain things happen, we can write telemetry into application insights and be able to get all of the information. So you now have maybe an end-to-end view, depending on how you integrate with application insights, of exactly how this whole environment is performing and the flow of a specific picture all the way through the process. So this is awesome. I don't see any questions in chat, so I'm assuming that everybody is we do have one, excuse me. Where are event grids created? So event grids are created right inside of the Azure portal with where all of the other resources are created. So Zafar showed there in the portal. Yep, so there he is in the portal. All he has to do is hit add, search for event grid, and you'll see it in there. So it's just another feature that's part of the Azure environment. So you can just come out here and create your event grid topics, and that's pretty much all there is to it. So just like creating a function or storage account or any of the other serverless components, it's just all directly inside of your Azure portal. Now, there is one caveat, and I know we're a little over in what we normally go. We usually try to go 30 minutes, but we're a little over. But I think this is important. One thing to be aware of is that there are some differences between our Azure government and our Azure commercial regions. So if you have specific requirements to be inside of an Azure government environment, you'll definitely want to make sure that you read through the documentation because there are slightly different I believe connectors for logic apps and also different models for deployment for function apps. How do you migrate, deploy a dev or staging environment account tenant to a production account tenant? Okay, so what I recommend, so let's say that you've got a dev environment or staging environment and you've got your code in there and you've tested it. Normally what we would recommend is that you have created this through a DevOps pipeline. And I know we're not really talking much about DevOps in this specific scenario, but normally what you would want to do is do a DevOps pipeline where your function code is checked into source control. And basically when you check in your source code, it can go through the process of the pipeline of actually deploying into the proper environment. And as part of that deployment, it may even build these for you. So one of the things we didn't talk about, which is a little more of what I'd say a foundational component of Azure, is called Azure Resource Manager. So Azure Resource Manager is a templating model for Azure for building resources. And so you can create these ARM templates that define your infrastructure. So it's kind of like infrastructure as code or services as code that defines all these services, and then it goes through and can build that out for you. So you can have that as part of your whole DevOps pipeline. How does the app behave if one of the functions errors out? Okay, so if one of the functions errors out, there's actually logging inside of the function app itself. There is logging that actually will show each run. If we get, it's been a while since I've played around with this. Go into one of those and expand one of those open. You'll see down a monitor on the left side in the drop down under get upload URL. You can click configure your application insights to be able to get that information, so you can see that. That's where application insights really comes in handy. But you can also, if I remember on the root, there's logging there also. So you've got a log window there that will actually show you if errors have been occurring in the invocation of your functions. So personally, I would include error handling of some sort, of course, in your function, and then use that maybe to do some sort of alerting notification. You could push that into application insights so you can run reports on errors that are happening, or of course you can come out here to the portal and look at the logging. Yeah, so like he's showing you there, there's the log streams, etc. So you can actually get the logs to bring down. So that's a good question, because that's one thing that you're definitely going to want to think about as you're building these applications is error handling and logging. Logging is going to be extremely important. That way you have all the data that you need to be able to diagnose any kind of problems that you've got. These are great questions. Thank you. Anything else? No? Zafar, was there anything else that you wanted to bring up before we wrap up?
I'm so sorry. I've been talking on mute. I've been trying to show all this monitoring and stuff and trying to talk, and I'm like, why am I not getting a chance to talk? In any case, so like I showed for the monitoring, like Mike was already mentioning, you have this monitoring on the function app level, where you can go to log streaming and look at the streaming for all your function calls while those functions are being executed by your front-end app or any other app that's actually calling into these Azure functions, or the Azure functions are being triggered because of the blob upload or some HTTP requests coming in. So coming to that point, I forgot to mention about the triggers, right? Like I did talk about the triggers, but I didn't show you here on the portal. So when you're adding a function to your function app, these are all the triggers that you have available that you can see here. What I have used, or what we have used in the sample that I showed you, were HTTP trigger and the blob triggers. Basically, HTTP trigger is whenever there's an HTTP request coming in, then this function will basically be triggered. Or for blob trigger, whenever there's an image uploaded to a certain container in the storage account that you're listening to, or basically, it will trigger the Azure function from that upload. And there you have various other triggers available, like Cosmos DB trigger, Event Hub trigger, and several others. I mean, you even have the GitHub webhook or GitHub commenter. So several of them available for you to use.
So Sean asked, can you set up a template or environment to manage whether or not the function is running in, say, development or production? So Sean, that really goes back to what I was talking about, the ARM templates. So when you create the ARM templates, you can actually parameterize your ARM templates, where you can have the template define the services and the relationship of the services that need to be deployed. And then you can have specific parameters in there that define where in Azure you're deploying those to. So you could define a specific data center region, a specific resource group that you're doing, and the subscription that you're doing this in. So for example, some of my customers may choose to have a separate Azure subscription for dev test and a subscription for production. And that way they keep them completely separate, and they can put the proper role-based access controls on those subscriptions so that the right people have access for managing. So inside of your ARM template, you could say, if this is going to be deployed to production, we've got a specific set of parameters. And if it's going to be deployed to dev test, we've got a different set of parameters. And you can make that as part of your DevOps process, as part of the deployment steps to make the decision which way it's going. Usually what happens is step one in the deployment process is deploy to dev test, and then we pause and wait for approval from someone to say, now we're going to deploy to production. And then whoever that approver is, if they say nope, then it just ends right there, and that code only stays on the dev test environment. Or if they say, yep, it looks good, and they accept it, then it goes ahead and pushes that out to the production environment. So that's where the Azure DevOps pipeline really comes into play here. And you're going to see this more and more across Azure, and just going forward in the future is going to be this concept of not doing things manually, making sure that we have a very repeatable process that's scripting based, that's pipeline based for taking something that you're building and getting it to its ultimate destination. So I would definitely focus heavily on the DevOps side of things from a maturity model for organizations to kind of get to that higher level of maturity in a DevOps model in order to be able to automate some of those things. And this doesn't mean that your administrators and people that are doing deployments today don't have a job. It means that their job's going to just change a little bit. They're not going to be manually, typing code or copying files. They're going to be overseeing these pipelines. And this is a perfect example. Here's the deployment center inside of Azure that allows you to choose where the source is for your Azure function code. It could be coming out of Azure repos. It could be coming out of Dropbox. So wherever this code is, you can define it here and then configure how you want that to be pushed out. So it's really, really a powerful capability that we have built into Azure and into Azure DevOps. If you've never used Azure DevOps before, I would go out and look at it, especially as developers go out to look at Azure DevOps. It's free for up to 5 developers. If your developers have Visual Studio subscription licenses, they get to use Azure DevOps as part of their benefits. So I would definitely look into that, and that would help you kind of get from your end to end. Yep. So it's a great, great, great solution here. Excellent, excellent. Well, I know, like I said, we were a little over. We try to keep these at about 30 minutes. We do allocate an hour time. Any other final questions before we wrap up? And I just want everybody to know, once again, next month we're going to have another one of these sessions. There are also other sessions that are available on the Azure Ninjas site. So if you go to azureninjas.com, you will see other sessions that are not dev focused. They are focused more on infrastructure or security. So feel free to go out to that site and look at the different sections for the other types of webcasts that some of our other teammates put together. With that, I would like to thank Zafar for doing the presentation today. Really appreciate that. And I want to thank everybody for coming out and spending time with us today. I know everybody's time is very valuable. So thank you very much. Have a great afternoon.